Hello to all the virtual students. We're going to start this early. You might need to fast forward through some of this. What? I don't actually. No. In fact,
my COVID shot at 8 o'clock, and it's making me feel really sick and nauseous.
that's something that I have to get. I don't have it.
Okay.
Otherwise, I would.
Why does Corbin what? Not you. The other Corbin. Oh, yeah. It shows his like her challenge.
Get homework tonight? No, we do. On a paper. It's not surprising. I'm starving.
Okay, welcome. We got 3 new scenarios up on the board. They're dealing with angles. Scenario 1 over there, and arcs. Angles 1. Scenario 2 here, and then scenario 3. Please write them in your notes. We're already recording for our virtual students. Announcing real quickly too, I'm not sure if I told you this, I won't be here tomorrow. And
I'm sharing because I know his stuff.
okay, Annie, my daughter, is graduating from Cincinnati. And so my wife and I are going to head over there to be a part of that graduation ceremony. And anyway, so I tell you that because I want you to make sure you have your computer charged and headphones, because we're going to have a Canvas assignment. There will be a video posted that you'll need to watch. Got it? For tomorrow. Okay, so 3 scenarios. Get these 3 scenarios into your notes, and we'll get going for today. We got some wonderful, soothing background music that's going to play. I googled soothing sounds for studying, and this is what it gave us. Ocean sounds. I'm not responsible for what they gave us when I said search for soothing sounds for studying. This is what they gave us. Evan, you got all three written up? Okay, so let's go then. First thing I want you to do is turn to page 831. We're looking at angle relationships in circles. Angle 15.5, 831. Let's look at example number 4 at the bottom. As you turn there in your book, I want to talk about these three scenarios. Okay, I said a lot right there. Let me repeat myself. 831. Example 4. Let me pause our soothing sounds for studying. Example 4. Okay, so the scenario over on the board on the left talks about the arcs added together divided by 2. The most important part that I want you to pay attention to is where's the point of intersection? It's inside the circle. Here, where's the point of intersection? Outside the circle. Scenario 3, where's the point of intersection? On the circle. Inside, outside, on. And that changes the formula. When it's inside the circle in scenario 1, we add the arcs and divide by 2. Got it? Outside the circle, we subtract the arcs and divide by 2. On the circle, half the arc. Okay. That being said, now let's go to example 4. William. Met your mom last night, by the way. So I think I met your mom last night at the golf meeting. She's super nice. Why aren't you more like your mom? I'm teasing William. He's like, is he serious? She was very nice. All right, what's this say right here, William? Where that question mark is? Right here on the board. That's right. The little m out in front, the measure of angle, MPK. Where is that? It's right on the inside where the dot is, right there. Okay? And I have a dot here as well because those are vertical angles. That means they're congruent. Okay? All right, so then, since the point of intersection is on the inside, it's just like scenario 1. So we're going to take the equation, the numbers, we're going to add them together and take 1/2. Everyone see the equation? Let's solve it. What's 61 plus 111? 172. What's half of 172? 86. So that problem right there, measure of angle 4 is 86. That's already in your book there, so you can just write everything in your book. Page 831. All right, so on page 831, right to the right of it, I want you to go ahead and do number 5. Number 5, page 831. I want you to find the measure of arc RP. I chose pink today because Raven is wearing a pink mask. When I draw an arc, it kind of looks like I'm putting a mask on the circle. Okay, so now we set up the same equation, but our variable's in a different location. So in this case, our variable is now inside the parentheses, and then we set it equal to 58. I have a question for somebody out there. Chase. Is that a central angle? Look at point T. It is not a central angle. Even though it's, you're correct, it is not a central angle. Even though it's inside the circle, it's not considered a central angle. Raven, what would have made it a central angle?
If it was like with the diameter,
Okay, keep going.
like if it was, oh, if, no, that's, I don't know.
If the vertex is at the center of the circle, then it is a central angle.
Okay,
So the diameters are right.
Sure.
Okay, yeah, you're saying it, but you were on the right path. If it was like the intersection of two diameters, that would make it a central circle. Okay? Okay, so now we have 58 is equal to 1/2 x plus 82. What would you do next, Evan, to solve this?
I would just distribute the 1/2.
And I actually, myself, would rather get rid of the fractions. I'd multiply by 2. Either way, if you multiply by 2, you get that. 2 times 58, and get rid of the fraction 1/2. But if you distribute, you can still do it as well. Okay? And then we subtract 82, and so our final answer is 34 degrees. Questions? Corbin, you got it? Okay, Raven, what?
Like, how do you know this put the variable? Like, what?
Good question. What are they asking for in this one?
RP.
Arc, right? The measure of arc, RP, that's where I put the variable. So when you look at the problem, what are they asking for? Put the variable there. Back over here.
And how do you generate the equation to?
Okay, hold on. So back here, what were they asking for? The measure of the angle, right? So that became our x. Okay, now, what's the equation? Well, that determines where the point of intersection is. Point of intersection is inside the circle, then that's your equation.
Okay.
That makes sense? If it's outside the circle, then you would use this one.
Okay.
All right, turn to page 832. Let's take a look at number 6. 832, let me get it on the screen for everybody. 832, number 6. Which scenario is this picture like? Scenario 1, scenario 2, or scenario 3? Scenario 3, Lance is correct. The point of intersection is on the circle. Okay, and so then the angle measure is equal to half of its intercepted arc. Here's the formula. If the angle is half the arc, that means the arc is twice the angle. Hold on, let me say that again. If the angle is half the arc, then the arc is twice the angle. Right? Think of it like this. If 4 is half of 8, then 8 is twice 4. Anyone see that? Okay, so back to here. So if I have the angle, that's 61, then the arc has to be 2 times 61. 122. Does that make sense? We good? Nod your head. Yes, yes, yes. Okay, good. Let's go to number 7 right next to it. Do it on your own. find the measure of angle MNP. Number 7, page 832. Okay, what did we get? Cut it in half, 119. All right. Next thing, go to the top of page 833 and bottom of page 834. There are 2 charts. I want you to write those in your notes. Yes, they take a while. Don't complain.
Wait, what time?
833 and 834. Top of page 833, bottom of page 834. I mean, I'll even allow us to listen to this wonderful music while you take notes. Listen to the waves crash onto the beach. If I liked sand, I would like this much more, but I don't like sand.
What's your problem with sand?
Gets into your fingers.
It's everywhere.
We just had the last person take the exam. So if I were here tomorrow, we would, but yes, we will. Okay. In fact, they just took it second period.
You guys are fine, mine.
Yeah. once it's posted.
On PowerPoint.
Yeah. You got 94.
Percent. Cool.
I like to chart at the bottom of 834 because it puts numbers to it. It helps cement it in your mind. 833 is basically scenario 2.
Mr. Bennett, you never going to WDM on Saturday?
I'll be fine. Okay, starts. All right, now let's continue on. Turn to page 833. Let's take a look at example 8. 833, example 8. There it is. All right, well, first of all, a quick review of the charts. The one on 833 was basically scenario 2. It doesn't matter, listen closely, does not matter if it's a 2 secants, a secant and a tangent, or 2 tangents. That's what that chart's showing. it's still the same formula. You take 1/2 of their difference. Okay? All right, so here we go. Scenario 2. Tangent and a secant. We subtract these and divide by 2. So there's our equation. Subtract them and move it over. There we go. Subtract them, divide by 2. (161 minus 67) gives us 94. Half of 94, 47 degrees. Multiply by 1/2. Divide by 2. Multiply by 1/2. Okay. One last example. Everyone got that one? Turn to page 835. 835. Here we go. Get it on top of the screen for everybody to see. First question I have for somebody out there. Why is this 101, Corbin? Why is that 101? Take your time. That's right. It's supplementary to the 79. What type of angles are 79 and 101? Another supplementary. What are they called? Adjacent angles. Adjacent angles are always supplementary. Vertical angles are always congruent. Adjacent angles are always supplementary. Okay, so now here's our equation. 1/2 of the arcs added together. This is scenario 1. 1/2 of the arcs added together. Where's x? Right there, because that's what it's asking for. Arc KN plus 86 equals 101. I like to multiply by 2 to clear the fraction. X plus 86 is 202. Subtract 86. And we get 116 as the final answer. Questions? Quick review before I give you the assignment. You've got to determine which section that the intersection takes place in. Does it take place inside the circle, outside the circle, or on the circle? If it's inside the circle, we take half of their sum. If it happens outside the circle, it's half of their difference. And if it's on the circle, it's just half of the arc. You got to keep all 3 scenarios. Okay, here's your homework. This is due Monday. Like I said, I won't be here tomorrow. Make sure you have your computer charged. Virtual students, any questions, give me an email.